Let's conclude the discussion about time discounting. I argued that exponential discounting places insufficient weight on the distant future. And I showed you an alternative, Hill's hyperbolic discounting, but I said that's entirely ad hoc, you just insert a log somewhere. And I showed you Weizmann's gamma discounting, which seems to be much more reasoned, but also that is actually pretty ad hoc. We're interested in an intertemporal welfare function, let's call it W, and that is typically a function of a stream of utilities into the future. And then the conventional way of writing this down is that we have a stream of utilities and then we exponentially discount it with the pure rate of time preference, rho. Now Weizmann's argument was all about what is happening here, e to the power minus rho t. And he essentially assumed that what is going on here in this function is independent of what is going on here. And that is perhaps a problem. Now, this exponential discounting was in fact proposed by Paul Samuelson, who you see here. And that was an entirely ad hoc proposal as well. And it was later axiomatized. There's a number of axiomatizations of this. I'm going to show you the one by Koopmans. So what do we mean by axiomatization? Essentially what we want to do is, rather than suggest a function or propose a function, in this case a welfare function, an intertemporal welfare function even, instead of just proposing a function, as Samuelson did here, really what we want to do is say, well, these are the criteria or the axioms that this function should satisfy, and then if you have the right amount of axioms that are mutually compatible, then it follows that the function, the welfare function, must follow these particular rules and must have this particular shape. That is what we mean by axiomatization. And that is how you would want to approach questions like this. Now, this intertemporal welfare function that you see here with a discount factor has been axiomatized by Schelling Koopmans, who you see here. And Koopmans showed that an intertemporal welfare function cannot simultaneously satisfy strong Pareto and anonymity. That is, if this welfare function, intertemporal welfare function, works over an infinite time horizon. Now, what does that mean? Strong Pareto is just the intertemporal variant of Pareto efficiency, of Pareto superiority, sorry. And essentially, Pareto superiority means that if one is better off and no one else is worse off, then welfare improves. That is what we call Pareto. If one generation is better off without making any other generation worse off, then we call it strong Pareto. And that is obviously a desirable property for any welfare function. That's an axiom that we would like our function to satisfy. What does anonymity mean? Well, suppose that we have these two situations. So we have 6 students and we have 7 cupcakes. And then what is the best allocation of those 7 cupcakes? Well, you start by giving everybody 1, and then one of the 6 students, because you have a cupcake left, gets the second cupcake, gets 2. And then the question is this situation better than this situation? Now, the axiom of anonymity would tell you that you should be indifferent between the two. If you give an unexpected windfall to one person, that makes that person unexpectedly and undeservedly better off than the others, then you should be indifferent as to who gets that windfall, right? So what you would do if you have 6 students and 7 cupcakes is that you would give each of them 1 cupcake, and then you roll the dice and give the seventh cupcake to whoever comes up on the dice, right? After you've numbered the students, of course. That is a good axiom for a welfare function to satisfy. If there is an unexpected windfall, then we should be indifferent as to who gets it. Now, any intertemporal welfare function that had any form of discount rate, exponential or any other, violates anonymity. Because if this is the first generation, this is the second generation, and this is the third generation, first generation, second generation, third generation, if these people are sequenced in time, then obviously, if we have a positive discount rate, then this situation is preferred over this situation because the two comes sooner. So any form of discounting immediately violates anonymity. But Goodman showed that if you have an infinite time horizon, then you cannot construct a welfare function that satisfies strong Pareto and anonymity. Such a function simply does not exist. Now Goodman was a very religious man, so he knew Aristotle, what Aristotle had written about usury. He knew what St. Augustine had written about usury, and he was dead against discounting, but he had to discount. Essentially, he had to choose between strong Pareto and anonymity. And his argument was that strong Pareto is a desirable property, anonymity is a desirable property too, but anonymity is very strange in an intergenerational context. If I have to choose, one of 6 students gets an additional cupcake, then I should be indifferent because students are all equal, and definitely as a professor I should treat them all equal, even if sometimes they're not. But if you do this about generations, then essentially you should not be able to distinguish between your grandmother and your granddaughter. Of course we can tell these people apart. Of course they are different. So for those reasons, Goodman says, well, I'm going to sacrifice anonymity. If you do that, you get this particular or a intertemporal welfare function of this shape. You have to have some form of positive discounting. So people who argue for a welfare function that looks like this with rows set to 0, some people, actually quite a few people do, they violate strong Pareto, essentially. That is the implication. So that is what Goodman said. This is an impossibility theory. It is impossible to construct a welfare function that satisfies Pareto but does not have discounting. Now, this is true. There is just no, it's a mathematical proof essentially, so there's no 2 ways about it. The question then is, can we change the axioms such that we have an intertemporal welfare function? Now, the first one to succeed there is Graciela Cicciolniski, who you see here, and she said, well, the axiom of anonymity is all good and well. I'm going to replace it with 2 other axioms, an axiom of non-dictatorship and an axiom of independence. Independence is an axiom that I find very difficult to explain, but fortunately it is not important for this story. Non-dictatorship is easy to explain, and it is also important, and it is important for this story. So let's make a detour to overlapping generations. So your standard growth model, your intertemporal welfare function, essentially in the standard growth model you maximize intertemporal welfare. Essentially what we do there is we assume that there is this infinitely lived social planner, and that social planner decides everything essentially from now until eternity, and that is a very peculiar assumption to make. Now the alternative is to use so-called overlapping generation models. In an overlapping generation model you have economic agents who have a finite lifetime, just as we do, and they overlap in the sense that there's a young group of people, there's a middle-aged group of people, and there's an old group of people, and then the middle-aged group of people pay for the education of the young and for their care, and then they also pay for the pensions of the old people. And that is in the first period, and in the second period, middle-aged people have grown old, but then their children who were taken care of in their youth by the people who are now retired sort of repay them with their pensions, and of course at the same time they pay money towards the raising of their children, the grandchildren of the people I talked about first. So that is an overlapping generation model. Now, Peter Diamond showed that if you construct an overlapping generation model, and in that overlapping generation model you have someone in the beginning of time who is altruistic towards his children, and because his children are altruistic to their children, then indirectly altruistic towards his grandchildren, and so on and so forth, but does not make a distinction between his own welfare and the welfare of the people who come after him, right? So he's indifferent between whether he is happy or whether his children are happy. So that is one assumption that you need to make, and the second assumption that you need to make is that this initial person, the archfather of this dynasty, owns everything. So future generations do not have property yet, or actually will never have property. The current generation owns everything. Now, if you make those two assumptions, then an overlapping generation model is equivalent to a model that assumes that you have one infinitely lived economic agent who decides everything for the entire future. But this is essentially dictatorship of the present, because the current generation is assumed to own everything, that is dictatorship, and because they own everything, they can essentially set the path for the entire future. So this is dictatorship of the present. And Cicciolini said, well, I don't like that. I want a welfare function, an intertemporal welfare function that does not have dictatorship. There is not a single generation that is the boss. And if you impose these particular axioms, then what you find is that intertemporal welfare is a weighted sum of net present welfare, your standard thing, and the welfare of the last generation. The problem with operationalizing Cicciolini's work is the question, who is the last generation? What is the last generation? Is it the people in 100 years' time? Is it the people in 10,000 years' time? Is it the people in 100,000 years' time? It's very difficult to get your head around the question, what is the last generation? Unless, of course, the human race goes extinct. Now, in a later paper, Alvarez Cuadrado and Govan Long dropped independence, which is good for me because now I don't have to explain to you what independence means, and said, well, let's just have two axioms of non-dictatorship, non-dictatorships of the present, as Cicciolini did, and non-dictatorship of the worst off generation, or rather non-dictatorship of any other generation. So there should be two generations that are not the boss. Now that is indeterminate, so then they argued following roles that perhaps we should also assign special rights to the worst off generation, and then they come, and when they do that, non-dictatorship of the present and non-dictatorship of the worst off, then they come up with a intertemporal welfare function that looks as follows. It's essentially a weighted sum of the net present welfare, the old Samuelson criterion. Here we have it again. But now we multiply it with a weight, 1 minus theta. And we add the welfare of the worst off generation. That is here. There's no discounting here. And we multiply it with a theta, right? And of course, if we set theta to 0, we're back at the Samuelson criterion. Now that is what they propose, and it's an elegant proposal. Essentially it says nobody is the boss, right? It's not that there is a dictator in our intergenerational game, which is, I think, a good thing to have. And we place weight on the future, right? Because here we have something that is not discounted. So if climate change were to reverse economic growth, it would send the economy over a cliff edge, and people would get desperately poor because of climate change, then that is never discounted away. If climate change reverses economic growth and people in the future are getting worse off, then we place quite some weight on that. So that is good. The future cannot be discounted away, provided that the future is poorer than today. If, on the other hand, growth continues, if growth does not reverse, and we just keep on growing and getting richer, then the poorest generation is the current generation. And then we actually reduce welfare, reduce overall welfare, and reduce the social cost of carbon. So now I start talking about the social cost of carbon. What is the social cost of carbon? I talked about this before. The social cost of carbon is essentially the first partial derivative of this W to current emissions, right? And previously it was the first partial derivative of this term. It still is, but now that first partial derivative is multiplied by 1 minus theta, so it necessarily falls. And then we add the first partial derivative of this term, how climate change affects the burst of generation, right? But if the burst of generation is ourselves, if it's the current generation, then of course, because of the long delays, we actually discard a good bit of welfare. Now that is seen in these numbers here. So here we have our traditional Benthamite welfare function, or Samuelsonian welfare function, and then the implied social cost of carbon, depending on the pure rate of time preference that we use. It can be 25 or 105 or 296. So that is this bit here, and we want to take the first partial derivative of this bit here to current emissions, and it depends on whether you use a quadratic impact function, that is the impacts of climate change quadruple if climate change doubles, right? And if you do that, because you're only looking at the short term, you're only looking at the impacts today, but you ignore everything that happens after, even if you're not discounting, you simply ignore it, that number is pretty small, because the effect of climate change on today is simply pretty small. If instead we say that impacts are, in the long run, temperature to the power 6, as Marty Weitzman has proposed, then actually climate change reverses economic growth, and then you actually have a large impact in the future. In that case, the Rawlsian component of the Harris Quadrado von Long welfare function, then the first partial derivative of that thing becomes 20. And then the combination is 1 minus theta this thing plus theta this thing. And what you see is, well, these numbers, even if economic growth reverses, because we actually ignore, we only focus on the burst of generation, so we forget what climate change does to the rest of the generations. The weighted sum of these numbers and these numbers, regardless of the weight, is always smaller than these numbers. And that is what you see happening here. The Bentham-Rawls social cost of carbon is always smaller than the Bentham social cost of carbon. So this axiomatic derivation of an intertemporal welfare function, that sort of starts off as this is very appealing and we would like to do this and this seems like a sensible proposal. Actually, from a climate perspective, reduces optimal greenhouse gas emissions